Let's get started. Hello, everyone. Welcome to the MIT Mobility Forum, organized by the MIT Mobility Initiative. I'm Jinhua Zhao, Professor of Cities and Transportation at MIT. I'm so glad today that we have Dr. Jen Duthie and Dr. Dan Work joining us and to talk about the role of transportation infrastructure in the future of connected and automated vehicle. In a way, we say future, but actually it's very much here. And the question is how much it can scale up. As some context, Waymo's ridership in San Francisco last December or so actually surpassed the Lyft, become a major part of the player here, right? And plan to test its technology in over 10 new cities this year. At the same time, Apollo Go in Wuhan, China also has hundreds of robotaxi running around in the city now, right? So a lot of discussion about autonomous vehicle has been about the vehicle themselves. But today we'll focus on what about the infrastructure, right? With the vehicle achieving more and more higher level of connectivity and automation, how do we operate our transportation infrastructure differently? So we're really lucky today to have Jen Duthie, the head of research and innovation from Cintra, a four-wheel company, which is a leading transportation infrastructure company, owns and operates the long-term roadways concession around the globe, to really share with us their experience. And also, we have Professor Dan Work from Vanderbilt University to really share his comment and also the collaboration that Cintra and Vanderbilt have been having on this. Particularly with a question like AV deployment will be gradual, right? So one question is, will AV help even with a low penetration rate, right? And the second often asked question is, how would an autonomous vehicle and a human-driven vehicle really mix and behave with respect to each other, right? Overall, we encourage the audience to think beyond the concrete when we think about the infrastructure, right? Before I formally introduce Jen and Dan, I do want to reinforce the norm of this forum, which is everyone contribute one idea to today's discussion. Everyone, meaning all the audience, either in the form of comments or a question, which you can type directly into the chat. Let me introduce Dr. Jen Duthie, is the head of innovation and research at Cintra, a four-wheel company. Cintra is a leading transportation infrastructure company that develops and operates highway projects around the world. And in North America, Cintra actually have 50 years of project experience on 4 continents, include about 150 miles of roadways in North America. Jen earns the Bachelor of Science degree from Cornell University and a Master and PhD from University of Texas at Austin. And before joining Cintra, they actually spent 10 years at the UT Austin as a research engineer, teaching classes in a leading research group that focused on transportation network modeling. And then spent 5 years at the City of Austin's transportation department, leading the division responsible for traffic signal design, construction, and operation. Jen, thank you for joining us today. Professor Dan Work is a Chancellor Fellow, a faculty fellow, and professor in civil and environmental engineer, computer science, and the Institute for Software Integrated System at Vanderbilt University. He had led the research appointment before Vanderbilt in UIUC, Institute for Pure Applied Mathematics, Microsoft Research, and Nokia Research Center for Palo Alto. But I do want to mention one experience that's directly relevant to today's presentation. Dr. Work actually pioneered the method of controlling traffic, not using traffic light or fixed infrastructure, instead using vehicle themselves as a control to solve both monitor and control the road congestion. So without further ado, let me pass the forum to Dr. Jen Duthie. Jen, please.
Okay, thanks so much, Jinhua. Okay, let me share my screen. Okay, can you see my screen, Jinhua?
Very well.
Okay, great. Well, thanks everyone for joining today. It's definitely a pleasure. I'm a longtime MIT Mobility Forum attendee and fan, and so it's an honor to be here today with my collaborator, Dr. Dan Work. And today we're going to talk about the role of transportation infrastructure in the future of connected and automated vehicles. It is a broad topic. It is a topic that changes day to day. And the focus I'm going to take is on transportation operations. So, it has to do with infrastructure, but also how we operate the infrastructure. So Jinhua gave an overview of Ferrovial, and so I won't dwell on it too much, but just to say, Ferrovial has been around since about 1952, started in Spain. It's been in the US for quite a while, more than 20 years, in North America, and most of our business at this point is in North America, although we are truly a global company. And the unique part about Ferrovial is this integrative model where we work on the entire life cycle of these large-scale projects, and they could be highway projects, which is my focus today, airports, energy, renewable energy, and we leverage our in-house construction expertise to be able to be involved in design, build, finance, operate, maintain of the entire public-private partnership process. So I'll talk a little bit more about that as it pertains to Cintra. So Cintra is Ferrovial's highway business, and that's the business unit that I'm a part of. And we are also global. We are operating in 11 countries, 159 miles of managed lanes operated in North America, so US and Canada. And when we say managed lanes, we mean roads that are maintained such that they are congestion-free. We operate them to a high level of standard to ensure safety, efficient operations, creating a reliable path in communities that often experience a lot of congestion. So we manage that congestion through various mechanisms, including pricing that varies often dynamically depending on the conditions so that we can keep traffic flowing smoothly. And I'll talk a little bit about our digital business further in future slides. So I'll hold on that for right now. So the way that I organize this today, just to give you a sense, is the future of roadway travel and some key topic areas that we are thinking about and following closely. And then the future of roadway operations and what we're thinking in terms of what that looks like. And then what we're doing as a company to plan for the future. So, and it is interesting, as Jinhua said, the future in some ways is now. I mean, it's this, it's no longer, I mean, a very far future. We're actually seeing a lot of change today. So I'll start with the first trend or topic that we're following, which is the changes to the levels of autonomy of vehicles. Jinhua mentioned Waymo. So this graph here on the left shows that Waymo is increasing its weekly paid rides at an increasing rate. The overall number is still quite small, but really seeing a lot of success in the areas in which it operates: San Francisco, Phoenix, LA, soon to be fully operational in my hometown of Austin. But they are operating, fully without a driver within the operational design domain that they are adhering to. So as far as looking kind of into the future, there's a lot of different forecasts that I've seen about levels 4 and 5 automation. This graph here shows levels 3, 4, and 5. So I just picked one forecast just to illustrate sort of these trends, which is where we are right now, 2025, nearly zero of these higher levels of automation. But we really do expect to see a lot of increase into the future. And if we just want to look at levels 4 and 5, the highest levels of automation, we think the penetration rate's actually going to be quite a bit lower. So when we are planning for the future, we're thinking about not just some point in time when everything is fully automated, but we're really looking at a very long transition period where we have to operate roads that have varying levels of automation. So, what would it mean if there were Waymos operating on roads that we are operating today? What would it mean if there are, autonomous trucks? There are autonomous trucks, starting to operate in Texas. And then what would it mean if that's happening at a large scale? And how do we ensure safety when we have a mix of vehicles? So, we are really planning for this kind of long transition. A second topic that we're following is, what is this going to mean for the amount of travel? And I picked two of many research studies that are out there. And as we peruse the literature, what we're seeing is a pretty solid consensus that there is going to be an increase in travel because of these increasing levels of automation. And that can be for many reasons. It could be, the deadheading that we're seeing with, Waymo vehicles today. I mean, this happens even with ride-hailing vehicles that are not autonomous, but when vehicles are traveling without a passenger in them. So we'll definitely see more of that. We expect to see more travel of different types. So for example, long distance travel, people are reporting that they expect that they would take more long distance trips if their cars had higher levels of automation. That could be replacing airplane travel. It could be, you know, in addition to that, or just new trip making. And definitely looking to see more trips by different age groups, right? So especially younger age groups and older age groups that maybe aren't able to drive, or just generally people that don't have the option to drive might get that option as vehicles have increasing levels of automation. So another trend that we're following, and we are expecting the amount of travel to increase. The third one is the decision maker. And what I mean by that is, you know, right now, you know, I got my degrees or my graduate degrees in like transportation engineering, a lot of travel forecasting, and you know, we think a lot about, you know, what are the choice models, and assuming that the human is the one making those choices, right? You're deciding whether you're going to take a trip, you're deciding which mode to take, you're deciding your destination, you're deciding your route. And we think that the decision maker for some of those decisions might change in the future, certainly will change, or it's already starting to change for some of them, in particular route choice, right? So you might still be the one deciding, I'm going to go to work today, but the route might be completely out of your hands, right? And so as a roadway operator, it's important to us to know who's making different choices, right? If we are creating a roadway that provides a certain level of service or certain amenities, it definitely makes a difference if it's not a human, like we're not trying to communicate the value to a human so they can make that decision. Possibly it's an algorithm, right? Possibly it's you know, something other than the person. It's the vehicle itself. It's a software. And so we definitely need to take that into consideration when we're operating. It could be, you know, decision making even in real time, right? Do you change your route? Do you change your lane? And how we communicate and who we're communicating with is an important part of this problem. So, and the last topic that I'm just listing here, and this is not meant to be, you know, every possible topic for future of roadway travel, trying to keep my time in the time allotted, but payment methods. And as we operate priced roadways, this is important. This is a picture here of the facility that we operate at 407 ETR in Toronto, Canada. So this was the first open tolling toll road in the first open tolling toll road. And this is a picture of the gantry where there is technology there for reading toll tags. There's technology for reading license plates. You can see there's a lot of infrastructure in place in order to charge people for their use of the road. And we do expect to see changes to how people pay for transportation. This is an active topic of conversation we have with Jinwan and some of his colleagues, but we do expect to see kind of more of an infrastructure light approach. And are you charging a person? Are you charging a vehicle? And do we end up kind of going in a more technologically advanced way when it comes to charging for road usage? Is something that we're following closely. Okay, so future of roadway operations. As I was thinking about this presentation, what I kept coming back to is that the goal of the roadway operator is going to be the same, right? So the goal of somebody operating a roadway now is to operate it such that it is safe and it helps people get where they need to go efficiently. And I think it's still going to be an important role to play into the future. And the way that we are going to operate the roads might change, right? Right now, we provide signs on the side of the road to tell people what the speed limit is, or if there's a curve ahead. I mean, it's very kind of infrastructure, static information provided. We do have, there are additional feeds of information that people can get from, say Google or Waze or other methods. But the goal of the roadway operator is to look at the system as a whole, right? So I think that's a unique distinction. Like when we think about autonomous vehicles, they're looking out for themselves, right? How do I operate safely in this environment? And the roadway operator is looking at everything. So I see our role changing as providing information, not necessarily in the future in this like very static and it's always 50 miles an hour on this section of road, no matter what, to maybe giving guidance that's more continuous in time and space, and maybe even more adaptable or continuous depending on the type of vehicle or user, still with that same goal to operate the road safely and efficiently as a whole. But as we get more ability to communicate with vehicles and we have more capabilities ourselves for knowing what's happening on the roadway, that we can then optimize at a finer grained level. So, and I just want to recognize that there's been a lot of conversations about, do AVs need smart infrastructure? And if you talk to most autonomous vehicle companies, they'll say, we don't need the smart infrastructure. We have to be able to operate without it because not everywhere is going to have smart infrastructure. So, if I'm Waymo, I want my car to be able to operate regardless of which road they're on. And even if a road is a smart road, what if the communications go down? The Waymo can't not operate. And so I think, we're at a point where we recognize that AVs need to be able to have a certain level of performance, but there is value in data or information coming from the infrastructure that complements those vehicle capabilities. So giving them information that allows them to see beyond the line of sight and giving them trusted information. So a lot of the data that you're sent today is crowdsourced in one way or another. And as an infrastructure owner operator, we know that there's a road closure. We know that there's an incident or an emergency vehicle or some other non-recurrent event. And I do believe there is value in having that information be able to be transmitted to autonomous vehicles to help them make the choices that are beneficial for themselves and for the system, right? To avoid a certain road or change a lane or change their speed. So I think there will be a lot more fine-grained. Looks like somebody else started sharing their screen.
Yeah, sorry, Jen, go ahead, share again on that.
Okay, let me share again.
Yeah.
Okay. Okay, so you've probably heard this a lot if you're in the industry, but infrastructure is digital or will be digital as well as physical. Jinhua mentioned thinking beyond the concrete. I think that's in our abstract. That's definitely something that's true today. We do have a lot of technology on our roads. We expect that there will be a lot more in terms of communications and technology. What we're seeing, though, is maybe a little different than what we were thinking a few years ago, where we really need to be conscious of how do we achieve our goal of a safe and efficient system in a way that minimizes the cost, right? As a private company, we are working closely with the public sector, and this roadway will need to, and its infrastructure needs to be operated and maintained for a very long time. And so, we're working to optimize what is that digital infrastructure that we put along the road that can, also meet our goals and provide the value that it needs to, but minimizing the cost and not just the capital expenditure, but the operational expenditures as well. As far as safe and secure two-way communication with users, this is something that, needs to be able to happen. We've done a lot of work in the V2X space within the 5.9 gigahertz spectrum. And that is still, has a lot of potential for some conveyance of basic safety messages. But I think, we also need to think beyond that allocated spectrum and, what we're seeing as probably a future for a lot of this information conveyance is, having data sent by OEMs to some cloud and then somehow transmitted, and maybe that's in a paid way to infrastructure owner operators, who are able to kind of take that global view of the information and add the trusted, authoritative or trusted information onto it that the operator knows, and convey that back to users to help them make decisions. So, and I just wanted to end with something that's a little bit of a shift, but I've been talking mostly about cars in this presentation, but we are thinking a lot about transit as well, and what does the future of transit operations look like? And this, could be its whole own presentation. But we've been looking a lot at automated transit and what that can look like. And there have been some pilots of automated transit vehicles. And what we really think is potentially promising is a role for companies like ours to provide the infrastructure and also the operational capabilities to help manage multiple different kinds of autonomous transit vehicles on some kind of fixed or semi-fixed guideways. Kind of like we operate, roadway facilities now with many different vehicles, trying to be sort of manufacturer or vendor agnostic when it comes to operating, transit facilities that can be run efficiently as well. So we think there's a lot of potential there, and maybe fodder for future conversation. So my last slide is really talking about, what are we doing to prepare for this future? And, this slide is kind of a collage of the many different things that we're doing. Really testing the latest and greatest hardware out there, even doing some of our own development. Same for software. We are, testing the latest software solutions, developing in-house softwares where applicable, running tests and pilots and integrating into our current operations, because again, some of this is future, and some of this is, really kind of useful in the near term. Next Pass, so this was, I mentioned in an earlier slide, we have a digital business venture called Next Move, and Next Pass is the product that they have right now for users to be able to pay tolls without having a transponder or a toll tag. And so, definitely check it out if you're one that uses toll roads. But we also use this, on the innovation team as a way to test many different kinds of ways that we can convey information. Because again, there's going to be a long transition. So even while there are some, vehicles that we could communicate directly with, for a long time, we think that there will be a need for communicating via mobile applications or via car infotainment systems to users and not just the vehicles. So NextPass is a tool for us to kind of explore what the future can look like and how do we convey this information. We do a lot of in-house research. I have a picture here of one of my colleagues using our behavioral simulator, where we'll test out kind of new geometries, and just trying different technologies and seeing how people behave. And we can't do everything ourselves, so we do a lot of partnerships. So wanted to highlight here two of them, two of many. But top right, this is actually one of my colleagues. We were visiting Vanderbilt University, so kind of shout out to my co-presenter today, Dan. They have an amazing facility there where they're managing traffic. And we've had quite a good collaboration with them. And then bottom right, I extended the photo so that we could make sure to see Jinhwa's head there. That's our CIO, Dimitri's, presenting at the most recent MIT Mobility Vision Day, and which has really been, we're proud to be founding members of MMI, and really get a lot of value out of that group and other groups that allow us to network beyond other roadway operators, right? Or other infrastructure developers. Like, we need to be building relationships with companies that are working in the AV space, the tech space, And so, having this broader ecosystem is really important for us for preparing for the future as well. So I'm gonna stop there and cede my time over to Dan, and then I guess we'll get into a conversation.
Great, thank you so much, Professor Dan Work. Yeah, please. You're on mute.
All right, how about now? Can you all hear me?
That's good. Yeah.
Cool. And it should be just a blank white screen that's being transmitted.
Yeah,
that accurate?
Yeah.
Perfect. Awesome. Well, Jen, I really appreciated your comments. I mean, one thing I've enjoyed about working with Cintra and working with you particularly is that you're stuck operating systems today and also thinking through innovation about how to manage facilities that are going to have a wide variety of technologies, some of which you might control and some of which you might not. And trying to basically not just accept the future for what it's going to be, but try to partially steer some of the technologies to shape it. I'm also an operations person. I think it's pretty well understood that if we make travel easier and still do single occupancy or sub-person, nobody in the car occupancy vehicles, roads are going to get more congested. If you think about the way that roadways operate today, the video that you're seeing now is one that was filmed on TDOT's I-24 motion system, actually during an experiment that we ran with Cintra recently on this freeway. Morning traffic, pretty typical. These pockets of taillight waves that show up on the freeway are just like a constant pain of suffering on the freeways. These are instabilities that are generated from the ways that human drivers navigate. One person taps on the brakes, a person behind them taps on the brakes more than the vehicle ahead. You get this ripple effect where these waves of congestion propagate on the freeway. The challenge, of course, is like with that kind of stop and go wave, the dynamics of those traffic jams are so fast that they're actually relatively hard to see with conventional traffic monitoring systems. The typical install of radar sensors or inductive loop detectors averaged over 5 minutes. The dynamics are completely lost. So one of the pieces that we've been thinking through here in Nashville is how to build large-scale phantom traffic jam detectors. We really try to borrow the inspiration of some of the gravitational wave, large-scale instrumentation to say, well, wait a minute, instead of just like kind of guessing and extrapolating what happens in between different sensors on the freeway, what if we measured everything? And may get some feedback on the audio there, but if we measure everything, then we will be able to not just like estimate that that there wasn't one phantom jam, but we can root cause identify what the trigger was, and we can also quantify how many of those jams there are and what their features are. We've gone from a period where we know like models that can produce these to observing 20, 30 of these jams every single morning on I-24. So I-24 motion, really straightforward idea, measure everything. And if you measure everything, then we might be able to do some experiments with automated vehicles to understand how they behave in traffic and how we might be able to design those systems so that they can make traffic better for everyone. So if you think about those jams and you make the connection that they're generated by the way that humans drive, basically our perception and reaction times and how we have different choices about how fast we're willing to drive on the freeway. One option is to go into a classroom and teach every single driver to be better. I have excellent colleagues in education. I don't know how to meaningfully scale driver education at a level that can combat the phantom traffic jams that are on I-24. So that's really pushed us in a slightly different direction to say, there are a lot of promising technologies that are coming, even with the level 1 and level 2 vehicle automation. Think like smarter cruise controls that dynamically slow down when the vehicle in front of you slows down. And then the light bulb went off. It's like, well, look, if those systems are designed to not collaborate, to not cooperate, just to ensure driver comfort and driver safety, they might just organically be better than human drivers. They might organically be worse than human drivers as far as phantom traffic jams, throughput, et cetera. And after testing quite a few vehicles, we kind of concluded in 2018, 2019 that at least the conventional equipment that was being fielded in that era was likely to make the phantom jams just as human drivers do. So in that path, we really started down this pathway of saying, rather than trying to compete with the Waymos of the world who have much, much larger paychecks, brilliant people on the engineering side to work through some of the really hard problems of, level 4 autonomy. What if we just took the stock adaptive cruise control cars that are manufactured here in Nashville? You're looking at 100 Nissans that were donated to us. And we just basically rip out some of the stock adaptive cruise control systems and plugged in our own little Raspberry Pis to modify their stock driving behavior. And then call up 150 of our friends in Nashville and see if they might be willing to get in those cars running experimental control algorithms and drive on I-24. So you're seeing a snapshot of an experiment we ran funded by the US Department of Energy and the National Science Foundation, led by Alex Bayen at UC Berkeley with collaborators at Rutgers, Temple, Arizona, Tennessee DOT, Toyota, GM, and Nissan. We gave these vehicles to our friends on the street. They were all running modified adaptive cruise control systems. You're flipping now into the digital view of the freeway, and we launched these into that stop and go driving on I-24. Each of those vehicles was interacting with another, 200,000 travelers that traverse that corridor every day, with the goal of trying to mitigate just a little bit some of the stop and go driving that the rest of the human drivers create. And then we started thinking a little bit further, like, well, there are systems out there on the roadway today, classical control infrastructure that DOTs manage. Here's a picture of a variable speed limit control sign that basically uses radar or speed data from traffic conditions ahead and propagates that back on the sign so drivers don't have those high-speed rear-end collisions. Even if you don't adhere to the speed limit, if you can increase driver awareness and reduce crashes, it still has a positive effect. And if drivers would comply, then you could actually get rid of these stop and go waves. So one of the straightforward things we thought about was like, well, let's just pipe the variable speed limit control information that everybody else sees into the cars and force them to drive the adaptive cruise control system to drive exactly at what's posted on the speed limit. And here's an example of what that looks like. This is a robot video fail, if you're tracking. We are piping in the forced speed limit that the variable speed limit control system insists, and the adaptive cruise control is forcing the car to drive at the speed limit. Unfortunately, other drivers on the freeway don't drive at the posted speed limit. You saw a large truck that basically blasted by our vehicle that was driving at 35 miles an hour. That's what the sign said. The other driver was probably driving at least 20 miles an hour faster than us. And so this is the only car that's doing the right thing. And as you continue to advance, you can see our car is actually doing what it's supposed to, because we'll eventually find that same truck that passed us literally just a few seconds later on the freeway. So the variable speed limit control system is giving drivers the correct information. But if you're the only vehicle that is adhering to what the infrastructure is saying, you're going to be like a fish out of water. Everybody else is doing something completely different compared to what you're doing. And so some of the work that we've been thinking on with Jen's team is really about, well, look, how do you get drivers and automated vehicles to actually join together in these systems? The gantries that I showed you, I mean, those are expensive. So one of the pieces we've been working with Jen's team is like how to virtualize that information using the same sensor data that might be on a freeway, but without the heavy infrastructure cost, because then we could get that same kind of information to drivers. On I-24, just to be clear, when the system is actively controlling traffic, crashes are down about 12%. When it's not controlling traffic, the crash rate's up about 14%. So we know that those systems have positive crash reduction factors, but they're not scalable if you've got to hang up that physical infrastructure. Some of the work that Jen's team does with their Next Move application provides us an avenue to both collect information about traffic, but also propagate it to other drivers in the roadway so that they may be able to navigate more safely. And we can also think about trying to design the information we provide to automated vehicles that make them harmoniously blend in with the rest of the drivers, even when there's only a few vehicles that are out there on the roadway that might have that advanced technology. A lot more I could say on that front, but I think in the interest of having a vibrant discussion here, I'll just show a couple pictures of the folks that are involved on my team doing the day-to-day work, and look forward to the conversation for the rest of our time.
Wonderful. Thank you so much. I really enjoyed the combination of Dan work and Jen Duthie's both one from the industry perspective, the other one from kind of academic piloting experimental perspective there, right? So let me maybe start with, let me give you a hypothetical scenario and let's see how does it even at all feasible or can be thought about. So, traffic safety, right? One theory is saying it's not really the speed that matters, it's the variation of the speed between different cars that cause the problem, right? So therefore, can we imagine a time where instead of say regulate maximum speed being 60 miles per hour, we regulate the variation of your speed vis-a-vis the average of the neighborhood, right? So is this totally all of the realm of feasibility, or some kind of experiment or technology from Cintra or Vanderbilt, we can test that, try that? And also, what's the policy implication? Can we even introduce a law regulate traffic as such?
Well, maybe first cut, and then Jen, you want to, well, Jen, why don't you take the floor first? I'll follow up after you.
I mean, I think you're exactly right that it's often the variation of speed that can be the problem, right? Where we have maybe 2 lanes next to each other and one lane is leading to an exit ramp that's backed up and that lane is slower. That can cause some problems. The feasibility of the politics of it sounds like the hardest piece. I mean, you're the policy guy, Jinhua, so you can tell us. But I think that's definitely interesting. And as far as like what would be best for the system, you know, just theoretically, at least, it's an interesting idea. You know, as we start to see more AVs on the road and start to see them on more highways, like right now, Waymos are operating, you know, more on just local streets. You know, we're going to maybe have this conversation more and more, right? Are they going to go the speed limit even when nobody else is going the speed limit? And what are the safety implications of that? So I think this is a pertinent conversation, but I'm not quite sure what the politics of it are anytime soon.
Okay.
I would just hope that all the mathematical modelers that are on the call are immediately getting excited by the possibility of showing, you know, consensus algorithms and convergence proofs and things like this. You know, that video that I showed, which was the fail, I had the link for a paper we called The Middle Way to Traffic Enlightenment. It's kind of a joke title paper, but the idea was a smart one. It was to basically reprogram the switch on the car from eco, normal, and sport mode. The eco mode, we reprogrammed to follow the posted speed limit exactly according to the variable speed limit. In the sport mode, we actually used the local radar sensor on the car, that stock OEM installed sensor, to measure the traffic of the surrounding drivers. So if you turn to the sport mode, it would just literally force you to drive at the speed of your surrounding neighbors. Obviously, this was in a controlled experimental environment, so there's all kinds of safety protocols that go and make sure that stuff is done in a way that is safe and respectful to other drivers. But shoot, like you can actually program cars to do that. The convergence proofs, I flagged that for the modeler folks because it's not obvious that if you just throw together a random algorithm that blends in with the speed of other vehicles, that you won't end up doing things like gridlocking the freeway. We've seen with some of the rule-based approaches for variable speed limit control, that will happen unless drivers intentionally violate the speed limits. So these convergence arguments, there's a lot I think that would be needed there just from a technical point of view to make sure that the design, when one car does it, it's not a problem, but when everybody does it, you don't end up with these emergent features that were relatively hard to predict if you're only thinking about the world in terms of a single vehicle rather than thousands and tens of thousands of them on the freeway.
Right. If you compare with the animal behavior, like schooling of fish or the birds, etc., right? They, by nature, they don't have a global control. They don't have a traffic light, etc. They all regulate themselves through local behaviors of each other, right? Yeah. Let me move to the next question. I want to connect the phantom jam that Dan talked about to what Jen mentioned about who's the decision maker here, right? This phantom jam problem that Dan, you really contribute a lot to identify and measure. Now you can actually every day observe them, right? This is major discovery and contributing to that. So on that, connect to the point what Jen mentioned about when we talk about autonomous vehicle, right? If you look at it as a property right bundle, when you buy something, you have the ownership, you may transact it, you may rent it, but to what degree you still control it? That's an open question here, right? For example, typical would think if you buy an autonomous vehicle, the micro level control, you forgo it. Acceleration, deceleration, you happily forgo it. That's the point of buying an autonomous vehicle, right? But the middle level control, like the route choice, under what scenario it makes sense for some collective agency, either Cintra or DOT or some kind of central architect, to take that control over and make the whole system better, right? That's the second level. Then the high level, for example, destination choice, right? You may imagine you say, autonomous vehicle, I want to go to a restaurant, right? Instead of specifying specific why. The AV may say, oh, I know you try to be healthy today. Let me recommend you a vegetarian restaurant, right? I mean, you can imagine all levels of the humans let go certain degree of agency gradually to the machine on this, right? So for that, I hear both from you, both from like an infrastructure provider point of view or from the research point of view, anything we should study or what's the most important potential all of this discussion?
Dan, you want to start that one?
Yeah, please.
Yeah, I'll pick up on a thread there. I'm not sure I can answer the whole question, but I think the fact that people, as the technologies get better, don't care so much about the low-level details. And the low-level detail you could pick, whether that's the parameters in the adaptive cruise control, or like the specific routing algorithm, or even the destination. That actually opens up a lever, I would say, for good and for evil, right? The good, from a safety point of view, there's a lot of things that we can do there. If you're answering email and watching Netflix, maybe you don't actually care about the 0.0001% savings on your travel time that you get by driving too fast. And we know how fast driving directly relates to the chances that you're going to be involved in a fatality. So there's something beautiful. On the negative side, I mean, you can just imagine the fact that you don't pay attention to these details, how many avenues that opens up for new compromises. These phantom jams, part of the reason we've been so interested in exploring them, it's an emergent property of the flow. You could imagine maliciously designed systems in the interim where you could have people that are intentionally disrupting the flow, intentionally disrupting route choice algorithms, intentionally disrupting the types of control systems that we might still put on freeway and urban networks, that because we're not actively involved in the process of monitoring those choices that are being made, that things end up worse. And so I think part of the challenge for the research community is to both demonstrate the potential, but also put in the tools that can help us detect for potential abuses of those technologies.
Yeah, just to add on to that, I mean, yeah, we're in this kind of continuum of people have certain levels of choices in different situations, right? If I drive my own car, I have, complete control. I often cede my decision making on my route to Google Maps. If I'm in an Uber, or Lyft, I can tell them, I want to go this way or this way, but pretty much I'm ceding that. And I think that it is an issue today. I mean, one of the problems that we've been trying to unlock today is even the challenge of working with ride-hailing companies when we have dynamically priced facilities, that it's not always clear to the ride-hailing company how to best give the user the choice, right? Or to communicate the information. Like, we change our tolls on many of our roads, every 5 minutes. And so if you're getting into an Uber, do you have price certainty to say this is the toll I'm going to be paying? Or maybe there can be kind of a range, and what level of comfort are you okay with in that uncertainty of what your route is, or what the cost for your route would be, or the cost for your ride, and then who pays for what, right? Is it the Uber driver that ends up bearing any toll costs, and then that gets passed on to the person? So I just, like, there's little problems today that are maybe very small in the scheme of what we're looking at, but that we're, working to solve, because we think that they have, much broader implications as we try to think through, who's the decision maker in each of these little kind of micro instances. But I do see that, people will want, at least for a long time, to have that option of control. Maybe they choose to cede it, but they might want to, choose not to, and be able to keep that option. I'm not sure that they would, go for a global, orchestration scenario soon, but things are always changing.
Yeah, probably that could vary by specific scenario. For example, if there's an emergency evacuation program the government said, you may imagine that, let all the cars do carpooling. You have to bring 4 people, everybody work together on this, right? Versus in the weaker situation, if it's just for the sake of reduced congestion, you may not be that aggressive in intervening in that, right? So maybe the last question from me, I remind all the audience again, put your question, comments into the chat. I'll combine 2 sub-questions together. The first one is a Sloan professor of management, Charlie Fine, made a point about different clock speed of innovation across industries, right? So for example, softwares, they may send you like update every 2 weeks, right? In cars, we first have like 3-4 years of model. Now the Chinese company doing every 18 months to give a new model, right? But for infrastructure, we may have a new model every, 10 years or 20 years. Clearly, the different varies the speed on this, right? When the system, different part are taking lead in innovation, the infrastructure often the one that's slower to respond to this, right? So how do we, when, say, for example, Jen, you have to invest, say, $1.5 billion building this, but you had to anticipate by the time the project finished, lasting 20 years, the new technology will be next several generations up into this, right? Then a related question is, when you write a bid to the certain state DOT, how much tolerance or encouragement, if any, for you to really embed this new technology into your new design implementation of the infrastructures?
Yeah, good question. I mean, it definitely depends on who the DOT is and what their appetite is. But I think one of the interesting things about our business model or the public-private partnership is that you really can assign risk in the ways that make the most sense, right? It could be easier for us than the public sector to take on some of this technology risk, right? We can commit to we're going to provide a certain service or a certain level of service, and you know, we'll put out technology to meet that. But then if that technology is no longer the right one 5 years from now, then we're the ones, you know, taking on that burden of switching it out. Whereas I think with just the purely public sector model, it can be a lot harder. I mean, you know, thinking about for connected vehicle applications, the switch from like DSRC to CV2X, and what a burden that was. And, you know, it would be a burden no matter who invests in it, but it is a risk that I think the private sector is better able to take on and more nimbly handle. And that way the DOTs can think more about, you know, this is how I want my road to operate, or this is the type of information that I want to be provided, and don't necessarily have to specify, you know, I want you to use like this exact kind of technology, right? They might have some, you know, security conditions or other things, but don't have to, you know, get in the weeds in that way.
Mm-hmm. Thanks, Jane. Dan?
Yeah, I'm just thinking through. I have a 2-year-old cell phone. I drove a 5-year-old car, and I drove to work on a 50-year-old roadway. So the point on the timescales, I think, is absolutely spot on. And I pick off, I think, it was something that maybe David had put in the chat too, which is like one of the things that I think at least inspires a lot of the people that work at the Institute for Software Integrated Systems with me, is like trying to figure out how to give our infrastructure system somehow like super infrastructure capabilities. I don't know what exactly that means, but like let's try to take advantage of some of these things that are coming out of like the advances in artificial intelligence and data analytics and computer vision and blah 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 blah, and try to make our infrastructure a little bit more nimble, a little bit more resilient, a little bit more sustainable. There's a million ways that there can be pitfalls with that stuff, but there's also not really any other significant way around some of these problems. You know, we know that technology can enable 3x the throughput on a freeway. I mean, there have been experiments that were done 20 years ago. There are other reasons that doesn't work, but it's certainly cheaper than going to Jen's opener Beyond the Concrete, putting a freeway on top of a freeway on top of a freeway. I think we need to be careful about how we leverage those elements. The failure modes are a lot more extreme in infrastructure than they are in the cell phone. But I think we have a lot of opportunity that hasn't quite been tapped out on the infrastructure side that I'm definitely looking forward to exploring, I'm sure, along with many others on this call.
Cool, thank you. John, for the audience questions, please, John.
Okay, super. Thank you so much. Lots of great comments in the chat that we're going to share with you guys. Getting to the questions. Okay, so first one, Sal Tannenbaum had a great question about privacy. So Jen, why don't we start with you and then go over to Dan. So is protecting the privacy of drivers a goal of roadway operators, or is roadway infrastructure going to become an extension of the surveillance state? I'm thinking specifically of the need to cross state lines to access healthcare as an example. Now, this kind of gets into the role of who does what. And maybe you can say, as an infrastructure operator, we abide by law enforcement. That's a different role. But we're curious about your reactions to this question.
Yeah, it's a great question. We definitely, we do not keep personal information about, in many of our concessions, and it depends, every state is different. So some this is true, some isn't. Well, some we do the billing, right? And in order to do the billing, you need to have some personal information about the person who goes through. And in some of our some of our projects, we don't do the billing. And so we just send, maybe some vehicle identifier to another agency and they do the billing. I think generally, we don't want to have personally identifiable information about the drivers. Like our goal is to kind of operate the system in the best way possible. And if people want to, give us information that helps us, give them access to, sometimes we have, different discount programs, like that's helpful, but we have a lot of different rules and precautions in place to make sure that we're not, keeping very sensitive information about people, and certainly wouldn't be used for any sort of enforcement. So it's hard to say because every state is different, but I would just say right now, and we anticipate in the future, there are plenty of precautions in place that I certainly don't know, who you are. If you go through my facility and cross state lines, we have a lot of protocols in place for that.
Dan, any thoughts on, as we
Privacy matters,
migrate
full stop. I don't really have much more to add. Would love to go into a technical discussion on it, but privacy matters 100%. Those systems, I mean, the phone knows bits about you, your car knows bits about you, the infrastructure knows bits about you, even if it's not, even if you maintain PII, there's all kinds of side attacks that are vulnerable. It's a really rich area that I think deserves a lot of attention to make sure that information can't be inferred about you while you're traveling to get from point A to point B.
Yeah, it's a conversation happening in every domain as we digitize. So important discussion. Robbie Michelani had a question about equity. So the question reads, to what extent does the pricing or tolling consider equity? For example, anecdotally, Torontonians appear to think that Highway 407 as the highway of the elite. More broadly, what goes into the objective function when optimizing the infrastructure delivery and operations, and how are profit-making and social benefits balanced? Sorry to pass on these kind of thorny questions to you, Jen.
This is good. I mean, it's
the
something
question about sort of Lexus lanes, and how do you guys think about that with all the work that you guys do at Cintra with your express lanes?
Yeah, I mean, we talk about it a lot. It's a great question. I mean, I'll start with our express lanes and then we can come back to Toronto. But the way that the express lanes operates, which is all of our US facilities, it's a parallel facility to a general purpose lane that does not have any pricing on it. And so the idea with those is to have a path that is always free flowing, right? So you need to, get to your doctor's appointment or pick up your kids. You can do that and there is a cost associated with it, but it's not a cost that you're going to be paying every day. It's just in certain circumstances. And they also allow for, transit to have a free flowing path. And so, we price it in order to keep the lanes free flowing. And in certain geographies that does require, higher prices. It just depends on the income levels and various factors. We do have some kind of programs that are designed to help people that maybe couldn't even afford that one time to go pick up their kid if they're running late. And so that's definitely something we think about. 407 ETR in Canada and Toronto is different. It's a toll road. It does not have kind of a parallel general purpose lane. There are other highways in Toronto. So I would just say the objective function is pretty complex. We are a company that invests in building the infrastructure. So most of our facilities, we put in the equity, and even our more recent ones, we put in the money to build the facility. We'll even give the DOT a check. And then we, need to make back that money, right? Through pricing the facility. But really the pricing of it is focused on keeping it free flowing. And then we have, kind of parallel programs that will help think about, who are the people that need to use it and what programs can we put in place to help them out.
And I think, correct me if I'm wrong, but in general, transit buses can use the paid facility free of charge. So that sort of helps to facilitate public transport flow.
It depends on the geography. So some geographies that's true. It depends on the geography and the agreement. But often in many cases, there are benefits for transit vehicles and also for high occupancy vehicles. So if you're riding with 2 other people, often or in some cases, there are options to have that be a free of charge kind of ride. So typically there are ways to get around it, but every geography and agreement we have is different.
Dan, anything to add?
It's a good question. Nothing specific
Good.
I want to comment on there, just recognize the importance of getting a good answer for that.
Super. Okay, so Dan, maybe a question for you. I mean, really interesting work that you and your colleagues have done at Vanderbilt on these kind of phantom traffic jams. Just to be clear, I want to make sure I understood it correctly. So when you put the 200 Nissans onto the I-24, did it actually have a net result to improve overall traffic flow?
Yeah, the numbers are probably on the order of like 10% improvement in terms of the amount of energy that was consumed. I can't remember if it's energy or fuel. There's a series of 5 papers that just landed in Transactions on Control Systems Technology that it should be out this month on the topic. But let me talk a little bit more sincerely about what's going on there. The I-24 motion system came online the weekend before the 100-car experiment. So we had no way to digitize the waves until after the experiment took place. And the prior work that we were doing was driving a car in a circular parking lot, 22 cars. They created instability. We followed a really well-known experiment that was done in Japan by Sugiyama and their collaborators. The waves on the circular track were like oscillating on the neighborhood of 10 to 15 miles per hour. And then we got on I-24 and the wave speeds varied on the order of 50 miles per hour. So it was basically like we watched a cartoon about surfing and then found ourselves in the ocean at the largest break in history. So the waves are just much larger and much more powerful than we frankly anticipated. The effects were I would say modest but important. Where we could have been more aggressive and chose not to was we could have driven those vehicles in a level that would have absolutely had a more dramatic impact, driving at the average speed of traffic instead of the peaks and the valleys. But it would have put all those drivers right back in the same category of potentially driving 15 or 20 miles an hour slower than everybody else around. Running experimental AI controllers, that was just not a risk that we could bear on that kind of experiment. So we had to balance out a little bit the safety versus the impact scale. We are looking at ways to repeat those kind of experiments to carve out more of the oscillation. On a freeway like I-24, I don't think I would be willing to try that with a small number of vehicles without flashing lights, just because of the potential unintended consequences that those vehicles, while trying to do the right thing, create problems in their wake that could put other motorists at risk. So that's going to be, I think, a really honest and sincere challenge that this mix of autonomy that's trying to do the right thing in a fleet of vehicles that may or may not know what else is going on, that warm-up problem is a very real one. And that's kind of motivating some of that blending in work that we've been doing with the middle way controller. Once you get the penetration rate of a large number of vehicles doing a small thing, then you can start to dial the control up a little bit more to be aggressive without standing out amongst the crowd. That's going to be the challenge moving forward.
Good.
Thank you.
It's 1 o'clock. Sorry to interrupt here. Yeah. First, I do want to really mention the I-24 motion project is such a gift to both the academic world and also the whole industry there. So Dan and the Tennessee DOT, thank you for actually doing that, right? And also today, I'm really glad that Jen Duthie and Dan shared with us many of the latest thinking with the real world practice implication there, right? So thank you again for joining us. Everybody, please join me. Really thank both Jen and Dan for the presentation today. Yes.